now. Welcome back to Control Nautas podcast. We explore the latest technology shaping to the future of industrial automation. Today, I am thrilled to be joined by Steve Mustard, an independent automation consultant with over 35 years of experience in industries like defense, oil, gas, water, waste management, transportation, food and beverage, and IT, of course. Steve is the former president of ISA, International Society of Automation, and has worked for a wide range of automation projects, including cybersecurity of automation systems. Recently, Steve led a major digital twin project in the oil and gas production platform. We will discussing today about that. He also contributed to the comprehensive book to digital twins, making him an ideal guest for talking about this cutting-edge technology. If you find this content valuable, don't forget to subscribe, share this episode, and leave your thoughts on how and integrating digital twins into day-to-day automation process. Okay, for those who not familiar with the work for Steve, could you give us to the brief introduction how you became specialized in digital twins in this industrial automation?
Yeah, sure. Well, thank you for the opportunity to talk about this topic. It's a very interesting and lively topic. My introduction to digital twins was through a major capital project that I was involved in. That capital project had a number of initiatives to develop digital transformation related solutions that could help both the project and also the operations phase of the facility that we were building. And the digital twin idea was one to see if we could produce an electronic, realistic representation of the facility and, in fact, the entire field that could be used for reviews and construction planning and execution, and then also ultimately for a lot of activities that would happen in the operations phase. So an offshore oil and gas facility, you have a lot of people traveling to and from the facility to do various activities. And one of the things that we can do is try and find a way to reduce the time spent traveling and also the time spent away, so that we could do a lot of the work that would normally be done on the facility, we could do it in the office. And that was one of the big drivers for introducing this.
Perfectly. What has been your most recent project, and how did you leverage the digital twins to optimize either production and design of operational efficiency?
Well, in the project phase, when we introduced a digital twin, what we were able to do was help with some of the activities that are traditionally done with paper and drawings and two-dimensional representations. We were able to use a three-dimensional representation of the facility to do things like material handling planning. So working out where, if you need to maintain pieces of equipment, how you're going to move them around the facility, for instance. If you've got a 3D representation, you can actually get a much better idea about how to do that. We also had things like standard operating procedure planning. So how are we going to maintain some pieces of equipment and the steps involved? Again, it's much easier to do that if you've got a realistic representation of the facility in front of you. The bigger deliverable from the digital twin is in the operations phase. So the project, this kind of project lasts 4 or 5 years maybe, and the operations phase might last 20, 25, even 35 years. So if you can save on an activity over 30 years, then you can have very significant savings for the organization, not just in terms of cost, but also improved safety and just improved turnaround and lower risk in terms of loss of production or loss of containment because you're maintaining things better. So a huge number of benefits from like being able to do maintenance planning on shore and identifying what's needed so that when you go to the facility, you've got everything that you need, like scaffolding, for instance, and you don't have to cancel the work and start it again. inspection planning. So where is something? How are you going to inspect it? What is the procedure you're going to do? Save time finding things on the facility because you know where they are, and so on and so on. So huge number of small on the surface benefits, but actually when you scale those up to many times in terms of instruments and actuators and pipes, and then you scale that up in terms of years, then it's a huge saving.
Perfectly. You talking that digital twins are applying during design, operation, and maintenance phases. Could you explain how you utilize a digital twin during the operational phase? What are key metrics were optimizing this process?
Well, so let's take the inspection process. So traditionally, for the inspection process, you have a team of inspectors, and they have to go out and do general visual inspection on piping and vessels to make sure that the corrosion is under control. And you know, the scale of the facility means that you have to basically continuously inspect the facility, and that's very expensive and time consuming. And also, because of limitations in bed space on the facility, you can only have a certain number of inspectors, and so it takes a long time. And so by the time you inspect something, you may have already had an incident because of corrosion, for instance. So one of the things that digital twins can do is, of course, a part of the digital twin is photorealistic, photographic information that you've captured. So panoramas using laser scan technology, and also point clouds that show you exactly how something looks physically on the facility. So you can actually analyze that information with machine learning now, right? So you can look at photographs, and you can use machine learning algorithms that have been trained over years with thousands and thousands of images that say this is corrosion and this is not corrosion, to identify possible areas of corrosion. So you can save a lot of time in terms of analyzing, because it might take only, say, a month to scan the entire facility with a camera, and then process that maybe another month. So in 2 months, you can do the analysis of an entire facility that normally would take you maybe 3 or 5 years even, right? So that's a huge saving, not just in terms of people and time, but also just in terms of that risk reduction, because you're finding out these problems way before they become a serious threat.
Excellent. One of the strengths of digital twins is their ability to integrate to data in various systems. How do you manage the integration data like a MAS, ARP, or PLC system to create an accurate and dynamic digital twin?
Yeah, that's a great question. So there are different types of digital twins that people create. So simple version is a 3D model that shows you physically what something likes, and that's useful for certain use cases. But integrating data with that 3D model is where you get the real benefit. So you can start with basic data like P&IDs and instrument tag and pipeline IDs and attributes of those assets. You can combine all of those, and then you can be much more informed. But then what you're alluding to is then you can bring in other systems of record that organizations have, and you can start to make huge improvements in terms of efficiency and reliability by analyzing all that information together in one place. So traditionally, a lot of those systems would have been linked with either dedicated interfaces. Maybe the system has an API, an application programming interface, that allows you to make calls and retrieve data. And so you can implement those point-to-point solutions to collect all that data together. But the way a lot of digital twins are going these days is to use knowledge graph technology. So knowledge graph technology allows you to make relationships between different attributes of something. You can establish those relationships, and then as the attributes might be updated, the relationships stay the same. And so it's much more efficient in terms of being able to connect all of those things together. And not only that, but of course, any particular asset can have many different attributes. So, for instance, an instrument might have a certain set of asset attributes, and an actuator might have a different set of attributes, and so on. But you can maintain all of that much more readily in a knowledge graph, and that kind of technology, I think, we'll see a lot more of in digital twins going forward. So you can essentially, the old days, people used to create data lakes to kind of merge all of this data from different systems into relational databases that would allow you to do queries on different types of data. Or maybe you had some reporting system, a business objects type thing that would sit on top of your collection of databases and allow you to kind of query lots of different databases and get results. But as I said, now Knowledge Graph makes it so much easier to do that kind of thing. And then you put in place something like Power BI from Microsoft, and then you can do all kinds of amazing queries that you previously couldn't do. But finally, the really important thing is not to forget that with the digital twin, it's not just about the data reporting, but it's also about visualizing that in 3D space, right? So the power of the digital twin, as far as I'm concerned, is not just that you can connect all of this data in a knowledge graph. You can do that with the knowledge graph itself. But when you connect that to a 3D environment, now you're starting to say, I can look at a valve and I can look at the maintenance history of that valve. I can look at the work orders that are scheduled in 6 months' time for that valve. I can look at any permits that are related to the valve or the area where the valve is. And I can even look at, as you mentioned, real-time data. So I can look at, the status of the valve. I can look at the flow through a pipe, the pressure, temperature, whatever it might be, all in one place. And instead of just looking at individual streams of data and trying to understand the situation, now you've got this situational awareness that comes from bringing all this data together. So the valve is in this position, and it's been in this position for a certain length of time, and the pressure is such and such, and the temperature is such and such, and it was last maintained on this date, and lots of other things that you can do that can help you then deduce, what might be happening more readily.
Excellent, excellent. In the way of implementation challenges, what have been your biggest challenges when you encountered when the implementing digital twins and layer scale environment, industrial environment, and how did you overcome them?
Well, the the to me, the single biggest challenge I'm going to say is the quality of the data, and that can be any of those data sources. So it can be the 3D model itself, but it can also be the tag attributes. It can be the P&IDs. It can be the systems of record even. So even on a new facility, on a greenfield site, their companies will have standards, they'll have templates, they'll have formats for things, they'll have requirements that go out to vendors. But the challenge is that often those requirements aren't either completely met or maybe not even met at all. And so you end up with, for example, a 3D model, which looks visually correct, but you can't do anything with it because you can't select the valve or the pump that's on the skid. And so you can't do the kind of analysis that I was just talking about. Um, Even documents, if you don't make documents text searchable, for instance, then it's such a simple thing, and yet without that, you're unable to maybe connect those documents to other documents because you don't have the ability to find things in the document. So that's a challenge. Now there are standards, information handover standards, CFOS, for instance, and others that exist. I've yet to see capital projects really fully embrace those. Now, that might be just my own experience, but I don't see, even though those standards like CFOS have been around for quite a long time now, I don't see people fully embracing them yet. Now, I think that comes from the asset owner. They have to drive that, so they have to specify that. The problem is, I would say, is that the EPCs and the other vendors who are involved in projects of this nature will maybe not want to embrace those standards because they have got procedures in place already for doing things, and they do things in a certain way, and changing those procedures and processes is going to be difficult. But honestly, the thing is, it's everyone. to be able to have this quality of data. So even the EPC themselves, if you can make a project successful for your customer and you can deliver it on time or earlier, and you can deliver it to a high standard, that's good for you. So if you can use the technology to help you do that, then why not do that? So I think we'll see over the next few years more embracing of those kind of standards and methods, and we'll see projects be a lot more successful as a result.
Perfectly. As you said before, one of the biggest advantages of digital twin is the predictive maintenance capabilities. How accurate can this prediction be in the projects, and how do you handle the dynamic variables that affect in the real-time equipment performance?
Well, yeah, predictive maintenance, I guess, like everything, is only as good as the data that you have, right? So again, if you don't have the information, or you don't have it in the format that you need, it's going to be difficult, or you're not going to get the right result. So I think a lot of predictive maintenance projects have failed because either the data wasn't available, or wasn't available in the right format, or the analysis made some assumptions, and it wasn't correct based on the data. But I think clearly, what we've seen over the years with especially rotating equipment vendors is that they have established now, I think, very good predictive maintenance type methodology. So they not only do they put in place control panels and control systems for the turbines, for instance, on the facility, but they now make a connection. They collect data, then they connect remotely, they pull all of that data on a regular basis, and they're doing real predictive analysis. Now, they understand the machinery because it's their design, and so they can really understand, what is going on based on all of these different parameters that they're pulling. So I think with the digital twin, what you will be able to do is, going back to what we said earlier, let's pull together all of those systems of record. Some are static but temporal, like work orders, for instance. Some are dynamic, like real-time data flow and pressure, for instance. And you can, I guess, going back to what we were talking about earlier with data lakes, once technology became cost efficient enough that people could just collect everything, people started to collect everything and then started to mine that data to look for patterns in the data, right? So we think we know what the pattern is, and we think we know what data we need to analyze to get the result. But actually, sometimes the result is a different combination of variables that we didn't previously realize because we didn't have that ability to analyze it. So I think now with AI, especially generative AI, I can see the possibility of, kind of asking questions and pulling together the huge amount of data that we have, all in context, and then start to say, we flag up things which we previously didn't even think we were looking for, and allow, at least initially, humans in the loop to try and discern whether that's real or not. So going back to my example of the corrosion monitoring with the images, we don't currently say, we analyze the photo and say, this is corrosion. What we do is we say, this might be corrosion, and it looks bad. It looks like high, medium, or low, and then give that to an expert who can look at the result and say, that is. And so one thing you get out of that is, of course, you see where the areas of real concern are, and you can focus on those, but also you can feed that information back into the algorithm to improve the quality of the result, right? So same thing goes for every other aspect of predictive maintenance. If you start to have that human in the loop to look at the recommendations, if you like, from the analysis that you get, and you start to feed back, yes, this is correct, this is wrong, then you're going to actually just continually improve the quality of the analysis as well. So I think that's the way I can see it developing.
Excellent. Let's talking about the emerging technologies. They use the argument and virtual reality alongside digital twins is growing. Do you think these complementary technologies will become a standard in the factory of maintenance and training?
Yes, this is an area I think that can be hugely beneficial for many different reasons. So even if we're not talking about an offshore facility where it's time consuming and expensive and risky to travel to the facility to train and to learn, even if you're talking about a factory onshore, um, the number of things that you can do with a realistic digital representation, which fully represents the plant that you're maintaining or operating, is that you can do very, very, very realistic training. So you can have someone in front of a screen, or you can have someone wearing virtual reality or augmented reality glasses of some kind, or you can have an immersive solution like an igloo, one of these things that projects the imagery onto the planes of a wall and ceiling, so you actually feel like you're in there. And with a realistic digital twin, which looks like the real facility, it's got the right colors and everything that makes it look real, looks photorealistic, and an environment where you feel like you're immersed in it. Now you start to feel like when I'm planning the operation, when I'm identifying the valve I need to turn, when I'm moving to look at the dial I need to look at, now you actually really feel like you're really there. So not only do you improve the experience, you get better trained people as a result, and you also have fewer mistakes as well, because you can not only can you do it once, but you can repeat that exercise multiple times, and you can improve it. You can find better ways to do things. So I think the training thing is huge. One thing I would add, which we haven't touched on too much yet, is simulation of the process. So another type of digital twin traditionally is just a simulation of without any visualization. But again, if you bring that non-visualized process simulation and you connect that to a digital twin, and then if you connect that to your training environment, now you've got a huge improvement in terms of learning about how things operate. So not only are you saying, look at where you are, look at where the valve is, but you can actually select the valve, open the valve with a controller, and you can have the process simulator run the process simulation as if that valve was turned, and you can see the result on an HMI to see what happens as a result. Or you can do something on the HMI that makes something happen in the environment, and you can see what happens. So that is huge, and it's all possible. It's just I don't think a lot of people have fully reached that point yet. That's a very advanced type of digital twin, but technically it's possible. And we've done some of that work as well, and we see the benefits. So I think scaling that up could be huge.
Excellent. Thank you. To wrap up, what advice could you give to the engineers and professionals that just starting with implementing digital twins in their operations? Many of them
Well,
they are for control,
yeah,
classic PLCs.
right, right. So you make a good point, because one of the things that automation specialists have had to come to terms with over the years is that the amount of technology they have to deal with has grown exponentially. So we used to be people who could calibrate an instrument loop and then maybe program a PLC or configure an HMI. But now we're being asked to implement virtualized distributed control systems. We're being asked to connect those to enterprise systems. We're being asked to connect to predictive maintenance systems. We're being asked to connect them to digital twins, and so on and so on and so on. And so yeah, the first thing is, people might say, well, digital twins, that's not really in my sphere as an automation professional. But actually, I really do believe it is. And I'm glad you have your podcast to talk about it, because I think people need to be aware that, if they're not already aware, that these things are out there, and they should be embracing them as part of their role as an automation professional. So one of the things you mentioned, ISA or ISA, and you talked about, the International Society of Automation. So that used to be very much considered, the instrument and the PLC functionality. Now they consider automation to embrace all of these things as well. And so going back to your question, what should automation professionals do? I think they need to learn about what digital twins can do. they need to help their organization implement those things so they can realize the benefits. And they should be part of that, right? So that they should, in my case, I'm an automation professional by background. I'm not a digital twin person by background, but I got involved in that because I understand, the automation, I understand the process, I understand those kind of industrial facilities. And so I can work with people who understand visualization and system integration and such like to build a representation, right? And that's what automation professionals can do. So I think, understand what's out there. And then also, I think training, so ISA, of course, does a lot of training, and some of the training courses they have are actually focused on digital transformation and how automation professionals play a part in that. And I think that would be really useful as well, because I think it makes the automation professional much more valuable, much more diverse in terms of skills, and much greater opportunity for them to get involved in future projects as things evolve. We're always concerned as automation professionals that automation actually takes away jobs because it removes the need for people. But if you're one of those people who's involved in the automation process, then you have a job that you're going to be able to continue to provide to as time evolves, right? If you've got all those diverse skills, you've got much more opportunity. And of course, I should say that automation doesn't take away jobs; it just changes jobs, right? So instead of having a job which just involves turning a valve every so many hours and it's not very fulfilling, we can have a job that actually involves analyzing stuff and being much more involved in planning and predictive maintenance, which is much more fulfilling. So yeah, so I think there's a lot of opportunities for automation professionals.
Excellent. Before we finish, Steve, I know you run a consulting firm that specializes in automation and digital twins. Could you tell our listeners more about the services that you offer and how they can get in the touch with if they are interested in working with you or learning about more about that, what you do?
Sure. Well, my organization has three main parts to it. One is the engineering or automation consulting part, which is helping organizations understand their automation strategy, identify gaps, identify weaknesses, and try and resolve those. A big part of that is cybersecurity. So I've been heavily involved for a long time in industrial cybersecurity. So helping organizations understand where their cybersecurity risks are and how to manage those is a big part. Um, Implementing projects like this, like digital twin. So if a company comes along and says, I think we should look at a digital twin, but I don't know where to start, we can help with that. So we can help identify the use case, we can help identify the business benefit, and then we can identify a plan to implement something like that in an agile way that is very cost effective. The other things that we do is we do have some automation related solutions that we offer, which one of which is SCADA related. So we have some products like these very specialist niche products that these are battery powered cellular devices that have small I/O count that can be deployed in locations where traditionally it's hard to collect process data. So in the middle of a distribution zone of a water network, for instance. And the SCADA that goes with that. So it's a SCADA as a service. So instead of having to roll out SCADA servers and maintain all of those, you can collect that data and view it safely and securely on a website. And then the other area is soft PLC. So I've been involved with soft PLC for a long time, written some articles about it. Soft PLC is, of course, a software alternative to having dedicated hardware PLCs from vendors. The soft PLCs benefit being that you can deploy that solution on many different hardware platforms and achieve the same result. And so that fits nicely into some of the strategies that some people have, right? As I said at the beginning, we can look at your infrastructure, we can identify gaps that you might have, like some data that you could collect with cellular battery powered devices or some automation with soft PLC, and then look at cybersecurity and make sure everything's done securely. So we kind of look at the whole picture. So.
Excellent. Perfect. Okay, in the description of this video, I will leave all the data for contacting with Steve if you need to require to talking with him and your website perfectly. Today, we explored that in detail how digital twins are transforming the way that we design, operate, and maintain industrial systems. Steve, thank you so much for sharing your experience and insight with us. Don't forget to subscribe Control Nautas for the next episode. We'd love to hear you how you apply technologies like digital twins in your work. Thank you so much, everyone.
Thank you.